Okay, next length of piston stroke. So for any pneumatic application, okay, for your project work, if you want to calculate length of piston stroke, okay, so further there are considerations. For a fixed diameter of a pneumatic cylinder, the length of the piston stroke cannot be as long as we want. Okay, so there is a relation between length of the piston stroke and the diameter of the cylinder and rod. This is because a large length of stroke will create a large mechanical fatigue on the piston rod. Okay, so if the diameter of the cylinder and piston is small, and if you try to get large piston stroke, okay, so then it will result in mechanical fatigue. Okay, what do you mean by mechanical fatigue?
Sir, fatigue means that oscillatory uh, stresses caused by.
Okay, what do you mean by mechanical fatigue? Uh,
So the stress or a failure causes due to the oscillation motions
hmm.
like vibration motions.
Okay. So if cyclic load is acting, okay, on any mechanical element, so that may result in initiation of a crack. Okay, and again, if the same load is applied on the same element, the crack may propagate. Okay, so finally it will result in cracks. Okay, so by considering this, so you have to design it properly, or you have to choose a proper cylinder for a required pneumatic application. So to avoid this fatigue, that means if you want a large stroke length, then you have to choose cylinders which are having larger cylinder and piston diameter, sorry, or rod diameter. To avoid this fatigue, we should select a bigger diameter for the cylinder and rod when it is desirable to have a greater stroke, which is the utilization of a corresponding nomogram. So already we discussed how we can make use of these nomograms. Okay, so we use this nomogram to find a diameter of the pipe. Okay, for previous topics. Okay, similarly, even you can make use of nomogram to find this length. Okay, so with the utilization of a corresponding nomogram, the allowable stroke with respect to the rod diameter and the applied force can be calculated. Okay, so you can get these nomograms. Okay, so you can search in Google and you can download the nomogram, and in a similar way, if you follow the procedure, okay, you can get the unknown values of a certain parameter. Next, speed of piston's translation. The speed at which the piston is translating in a pneumatic cylinder is a function of multiple parameters resulting from the manufacture of the cylinder itself or the control unit. Okay, so depending on the speed of piston translation that you are expecting, okay, so you have to buy the cylinder. Okay, so you will get the specifications whenever you are buying a cylinder, so you have to consider that. So it depends on so how it will be manufactured, and also the diameter of cylinder rod. Okay, so or the inlet pressure. Okay, so that also will have an impact on the speed of piston translation. How we are regulating the flow. Okay, so that will also have an impact on speed of translation. We have various flow control devices, quick exhaust valve. Okay, all this will have an impact on the speed of piston translation, that is extension and retraction stroke. Next, this means speed value for classical cylinders varies from 0.1 to 1.5 meters per second. So this is the range within which you can get cylinders. Okay, so you can achieve up to 1.5 meter per second. Pressurized airflow control valves. The operation of pneumatic cylinders require the utilization of specific control equipment called valves So almost in all pneumatic circuits, so you can find the usage of these valves, different types of valves depending on the requirement. So these are used to control the flow to the cylinder. Okay, so by controlling the flow, you can get desired movement of the piston. Valves are control devices used for selecting the flow direction of pressurized air. So for that we use directional control valve that will control the direction. Okay, so flow direction of pressurized air. To apply control signals like start and stop, even by supplying air. Okay, so you can actuate a valve. Okay, so air operated or pilot operated valves. Okay, so there this air itself is the control signal and that will be supplied from valves to regulate the pressure and volumetric flow. So for that you have flow control valves. Next, there are different types of valves: directional valves, non-return or check valves, pressure control valves, flow control valves, isolation valves. So we are going to discuss about all these in detail, and most of these are already familiar to you. Okay, first, directional valves. Directional valves are devices that have the ability to control the direction of pressurized air in pneumatic installation, that means in pneumatic applications or pneumatic circuits. The control of the flow direction is mainly utilized for controlling the behavior of the pneumatic cylinders. So that means whether it should have extension or retraction stroke. Okay, so at what speed it has to extend, at what speed it has to retract. All these things can be regulated. Each directional valve is characterized by the number of switching positions and by the number of pressurized airways that could be externally connected. So for any directional control valve, we have positions and you have ports. Okay, so those positions are called as switching positions. Okay, and pressurized airways are nothing but they are the ports. Okay, so if you consider 5 by 3 way valve. Okay, what do you mean by 5?
5 number of ports.
Number of ports.
And 3 is a position.
Position. Okay, so other name for ports is airways. Okay, pressurized airways nothing but they are the ports. So next, symbolic representations of direction valves and their operation. Okay, so whenever you are representing a direction control valve, you are going to represent with the help of some rectangular blocks and some arrowheads and lines. Okay, so in that symbol, so these rectangle blocks or these rectangles represent position. Okay, these switching positions of a valve are represented by a rectangle like this. The number of adjacent rectangles expresses the equal number of switching positions of the valve. So here, if a valve is represented using two rectangles, that is an indication of two positions. If a valve is represented using three rectangles like this is a representation of three-way valve. So we don't know how many ports, but with the help of these boxes, these rectangles, we can say how many positions a valve is having. Okay, so this is 2 and this is 3. The airflow path and its direction at each switching position inside the valve is represented by an arrowed line. It may be like this upwards, or it may be downwards, or it may be inclined. Okay, so they represent flow path, in which direction pressurized air will flow. Okay, so inside the valve, that is indicated by this line with arrowhead. The airflow shutoff is indicated by a T symbol. So that means, so here air cannot flow. So this is like closed position. Okay. The outer connections of airflow, usually called inlet and outlet ports, are indicated by lines drawn on the outside of the rectangle representing the normal or initial position. So these are the representation of external connections. The other positions of the valve operation are obtained by shifting the rectangles until the flow paths inside the valve correspond to the outer connection. So this is the representation of outer connection. So this is the representation of normally closed wave valve. Okay, so it is a two-position valve, normally closed, two position and two ports. Okay, so here there is a connection for initially there is a connection for closed position. Okay, so here initially there is a connection for open position. Next, the air exhaust flow path without pipe connection. So this is the representation of that. So here directly you are allowing air to escape to environment. Okay. Next, air exhaust flow path with pipe connection. So here there is a pipe. Okay. So through which air will be released to. It may be to atmosphere or it can be taken by another pipe. Next, symbol of a pressurized air source. So this is a symbol of pressurized air source. Next, operation of valve. So this is an illustration where, okay, so you can understand operation of two-port, two-position direction control valve and the corresponding pneumatic symbols. Okay, so this is the inside structure of a direction control valve. There will be a spool, okay, and there will be a plunger arrangement inside the cylinder. Okay, so depending on the position of this plunger, so you can have passage for the flow of air from one port to another. That is decided by the position of the plunger. Okay, so compressed airway is open. Suppose if the valve is in open condition, okay, or open position, the meaning of that is, so the valve or the plunger position will be like this. If it is a 2x2 way valve, that is 2-port 2-position valve, then so plunger position will be like this initially. Okay, so then there will be air can flow from 1 to 2. Okay, so here from this port to this port, air can flow. Next, suppose if it is a normally open valve, if it is a normally open valve, okay, so then without actuation, air can flow from this port to this. Suppose if it is a, if you actuate this valve by pressing a push button or by giving electric signal, then position will shift. Position shift may be from open to close. Okay, this is the indication of open. Next position may be this one. This is the symbol of closed position. Okay. Next, when you operate the valve, okay, so initially it was open, now it will become closed. Okay, so how it will become closed means, so this plunger will move, okay, that will move to this position. The plunger will move to this position. Okay, so when it moves to this position, it will block the port. Okay, so now even though you may be supplying air from manifold block, okay, but it cannot flow from inlet to this actuation port. So this port to this, there will be no flow of air because the plunger will block the path. Okay, like this it will work. So in here you can get two positions. One is open, another will be closed. During open position, so the position of the plunger will be like this. Plunger or spool. Okay, another name will be spool. Will be like this because of that air can flow. So when it is in closed position, the plunger position will be like this. So because of that, air cannot flow from inlet to actuation port. Next, so same illustration for a so 3x2 wave valve. Okay, so the two-state operation of a 3-port 2-position. Okay, 3x2 wave valve, 2-position direction control valve controlling a single acting cylinder. Okay, so now initially, so this is the position. Okay, so if it is open, okay, so it is normally open, so you will get this position. Okay, air will flow from this port to this. Okay, so inlet, and this is the pressure port, actuation port, and this is will be release. Okay, or you can consider this as inlet and this as outlet. Okay, so this is the air will flow from this port, then it will go to the port of the single acting cylinder, and there will be extension stroke. Okay, this is the first position. Then by actuating the directional valve, if you are able to switch the position, then this position will get actuated. Okay, during this position there will be no path for movement of air from this port and this one, so here it will get blocked. Okay, so next air can flow from this port to this one. Okay, now because of the spring in the single acting cylinder, okay, so it will retract, there will be retraction stroke, and air collected inside the cylinder that will come through this path, this port and this one, and it will escape to atmosphere, or it will be circulated in the line. Next, the two-state operation of a 4-port 2-position direction control valve controlling a double-acting cylinder. Okay, previous one was single-acting cylinder. Now it is a double-acting cylinder, and it is having 4 ports and 2 positions. This is one port. This is another. This is another port, and this 1, 2, 3, 4. Okay, these are the 4 ports. Okay, there are 2 positions. So initially, if this position is actuated, okay, so air can flow from this port to this. It is the indication of this line. Okay, next, simultaneously, so because of flow from this direction, there will be extension stroke. Simultaneously, the air already entrapped in the cylinder that has to come out through this path. Okay, that is represented by this line. This is one position. Next, suppose if we actuate the valve, okay, it will shift to this position. Okay, initially this position is actuated. Okay, by default it will be in this position. When you actuate the valve, it will shift from this position to this one. Okay, when it shifts to the second position, connection will be like this. Okay, so there will be connection between this port and this one. Okay, so that is the indication. So this is one connection, and another connection will be like this. So this one, from this port to this is one connection, and this is another connection. Okay, so during this, what will happen is, so air will flow from manifold block, and through this inlet it will flow to this end of the cylinder. Because of that, retraction stroke takes place. Okay, during retraction stroke, again air that is entrapped or collected inside the cylinder, that will come out from this port through this. Okay, next, there are symbols which are used to represent directional control valves. Okay, so 2x2-way valve, initial position normally closed. That means connection will be external connections are represented by these lines. Okay, so normally closed means initially, so there will be connection for this position. Okay, normally closed means so air cannot flow from this port to this. Okay, so because it is closed. Next, normally open means so air can flow from so inlet to pressure port, sorry, inlet to actuation port. Okay, that is normally open. So 2x2 means so two ports and 2 positions. Next, 3x2-way valve. Okay, so 3 ports and 2 positions. Okay, normally closed because initially by default this position is actuated. Okay, so when you give a signal, then the position will shift from this to this. Next, 3x2-way valve. Okay, so open because by default this position is actuated. Next 3/3 wave valve. Okay, so there are three positions. Okay, one is this position, another will be this. One more position is it is like neutral. Okay, neither this nor this. Okay, so that is the three position. It is like a neutral, or sometimes we call it as tandem center also. Okay, next 4/2 wave valve. So here there are 4 ports and 2 positions. 4/3, 4 ports and 3 positions. Okay, by default initially, so this position is actuated. Next 4/3, by default this position is actuated. Next 5/2, by default this position is actuated. Next 6/3, by default this position is actuated. Okay, so like this we represent directional valve.